हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स एंड डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका स्वागत करता हूं केमिस्ट्री वाला चैनल पे रिगार्डिंग टू जस्ट केमिस्ट्री। इन प्रीवियस वीडियो वी हैव डिस्कस अबाउट द जस्ट व्हाट इज द मीन ऑफ haloalkane and haloarine, further nomenclature as a common and IPSC, and further we have discussed about the isomerism in haloalkane and haloarine. Today we'll go with the just preparation methods of haloalkane. So first part we'll go with the just first of all this is the preparation methods of haloalkane. Haloalkane. In this series, first of all, we'll go with the just from the alcohol. How we can get haloalkane from the alcohol? This is the from alcohol. If we'll go with this, then by using different kinds of the substance as a halogen acid, just we can say thionyl chloride, and just we can say halides of phosphorus, we can get the different kinds of the halides by the alcohol. So in this series, first of all, we'll go with the A part, that is by halogen acid. Halogen acid. The right formula for the halogen acid is your HX. Regarding to HX, here will HF, HCl, HBr and HI. These are the halogen acid. If we go with the just reactivity sequence regarding to halogen acid, then HI will be more reactive because of, as we know that on moving up to down in a periodic table, size of halogen atom increases. So it will be convenient to dissociate the bond which is present between H and I. So it will more reactive. This is the just you can say electrophilic, or sorry, you can say nucleophilic substitution reaction. It's a nucleophilic substitution reaction. First of all, the type of reaction. After then, we'll go with the just reaction. This is the alcohol ROH. This is your halogen acid HX. Here this is the partially negative, partially positive charge. This is the partial positive charge, del positive and del negative. Here will removal of OH group in the form of negative and positive. So here will formation of alcohol ROH plus you can say H2O. RX, sorry, and here will formation of H2O. This is the haloalkane. Haloalkane. If we'll go with the further, if we'll go with the just as a HX, we'll take the HCl because of HF is in HF, F is more electronegative, so it may be just a reactivity too fast. So we'll take the first of all HCl. For the HCl, what will be? It's a very important reaction. If as HX is equals to there is concentrated HCl, and if we use just anhydrous ZnCl2, anhydrous ZnCl2 with it, then the mixture of concentrated HCl and anhydrous ZnCl2 is called as Lucas reagent. This is the Lucas reagent. In short, we will call it Lucas reagent. In short, we will call it LR. If we go with the reaction, then this is the ROH as an alcohol. This is the concentrated HCl. This is the anhydrous ZnCl2. Electronegativity of Cl is greater than the hydrogen. Same OH is greater than alkyl group. So here will formation of RCl as a chloroalkane plus H2O. If we go with this reaction, then this is the very important reaction. It's a first naming reaction of the chapter. It is called as Groves process. It is called as Groves process. Naming reaction, Groves process, and the mixture is called as Lucas reagent. If we'll go with the further, then Here will formation of chloroalkane in the form of white turbidity. White turbidity. What is the meaning of white turbidity? Whenever we'll add a small amount of the milk in the water, then whole entire water turns milky. That is called as white turbidity. So further, if we go with the just this kind of the reaction is also used to, it is used to just distinguish 1 degree, 2 degree and 3 degree alcohol. So this was about the first reaction. How we can distinguish about the 1 degree, 2 degree and 3 degree alcohol? We'll see. So we'll go with the further. How we can distinguish 1 degree, 2 degree and 3 degree alcohol? It's too important. Here Lucas reagent means ZnCl2 acts as a Lewis acid which is helpful to dissociate the COH bond. Remember one thing, ZnCl2 acts as a, this is the ZnCl2, it acts as a Lewis acid. Lewis acid, and it is helpful to dissociate, dissociate CO bond, yeah, you can say COH bond. This was regarding to ZnCl2. If we go with the just distinguish, then this is the test tube 1, test tube 2, test tube 3. If we will add the Lucas reagent in these test tubes, then what will be? If there is white turbidity at a moment, white turbidity, then 101% it will be as a 1 degree alcohol. Sorry, 3 degree alcohol. Why? I'll explain. If after 5 minutes, there is white turbidity, then it will be as a 2 degree alcohol. And if there is after 30 minutes or no turbidity, then it will be as a 1 degree alcohol. Why 3 degree alcohol is more reactive towards this reaction? Then let's see. If we go with the 3 degree alcohol, then reactivity of alcohol towards glucose reagent is 3 degree greater than 1 degree. The reason is just due to formation of stable carbocation. What is the meaning of carbocation? Carbo means carbon, cation means having positive charge. If we'll go with the 3 degree alcohol, then having the formula, just you can say 3 degree alcohol forms 3 degree carbocation like this. After the removal of OH group, this is the 2 degree alcohol. So 2 degree carbocation. For 1 degree alcohol, it will be 1 degree carbocation. And you all know, due to more inductive effect of alkyl group, 3 degree carbocation is more stable, 2 degree cation is less stable than the 3 degree, and 1 degree carbocation is least stable. So this is the 3 degree carbocation. This is 2-degree carbocation, and this is 1-degree carbocation. So, due to formation of the 3-degree carbocation, here reactivity of the 3-degree alcohol will be most towards the leucostation as compared to 2-degree and 1-degree. Okay. Now we'll go with the just suppose if there is neopentyl alcohol, then what will be the order or reactivity, means what will be the sequence? Let's see. This is very important question. It's a brainstorming question. So you can say this is there is if there is neopentyl alcohol neopentyl alcohol, then reaction will be according to rearrangement reaction by rearrangement reaction by 1-2 shift, means particular 1-2 shifts के through rearrangement reaction होगा. Why? Because of just as I told you, formation of the stable carbocation. So if we'll go with the reaction, then this is the CS3, CS2, this is the CS3, this is the CS3, and this is the CS2OH. What should be? According to just reaction, this is the HCl, this is your anhydrous, this is your anhydrous ZnCl2. So product should be CS3, CS3, this is the CS3, and this is the CS2OH. But this is not actual product because it's a just 1-degree carbocation. Here will formation of the CS2Cl. But here it's not right because of just it is 1-degree carbocation, means neopentyl forms just 1-degree carbocation. How? We'll see. This is the right product is your as follows. Right product will be CS3, this is the CS3, this is the CS2CS3, and this is the Cl. Here will formation of, you can say, 2-chloro 2-methyl 2-chloro 2-methyl butane. Why this is possible? If we'll go with the reaction, then the mechanism shows as follows. This is the mechanism के अकॉर्डिंग बात करें, then HCl first of all loses H plus ion. So this is the CS3, CS2 and OH, and that H plus attacks over the oxygen atom and forms CS3, CCS3, CS3, and this is the O CS2OH2, CS2, here will OH2, this is the OH2 and plus with the 1 lone pair. After then, this is the first step. After then, this will be as follows: CS3, this is the CS3, OH2, this is the plus, it withdraws the shared electron. So here will formation of the carbocation CS3C, CS3, this is the CS2 and OH2, CS2 and OH2 lone pair plus. So here will formation of neopentyl carbocation with the removal of S2, and this is the 1-degree carbocation, and 1-degree carbocation, as we know, that is less stable. So what will be? It shows 1-2 shift like this. This is the CS3, CS3, this is the CS3, and this is the CH2 plus. What will be? It shifts from here to here, 1-2 shift, Then it changes in CS3. This is the CS3. This is the CS2, CS3, and here will positive charge. This is the 3 degree carbocation. Means 1 degree carbocation changes by 1 degree carbocation changes by rearrangement of 1 2 shift, and it changes in 3 degree carbocation. Now CS3C, this is the CS3. Here is the positive charge, here is the CS2 and CS3 attack of Cl minus. So the product will be CS3C, CS3. This is Cl and CS2, CS3. The name of product is your 2-chloro 2-methyl butane. And as I told you, according to reaction, this is the 2-chloro 2-methyl butane. So this was regarding to if there is neopentyl alcohol. See the matter properly. Now the time to discuss about the formation of, this was about the chloroalkane. Whenever we'll take just as a HXHCl. Now the time to discuss about the important part. What is that? That is, if we are going to take HX is equals to HBr, then remember one thing, it should be 48% pure. Reaction will be your ROH. This is the HBr. Again, electronegativity of Br is greater than hydrogen, and here is OH minus. So here will formation of RBr plus your H2O. RBr are known as bromoalkane. This reaction may carried out. This reaction may carried out by direct reaction of you can say KBr and H2SO4. KBr and H2SO4. How? This is the KBr, this is the H2SO4 dissociates in H plus and HSO4 minus. Here will dissociation in Br minus and H plus. So here will formation of HBr plus KHSO4. Now this HBr can be used to change alcohol in bromoalkane. This is the RBr and this is the H2O. So this was the indirect method regarding to just your HX is equals to just HBr. If we are going to take just your iodoalkane as a HX is equals to, we can take HI. So regarding to alcohol, this is the ROH, this is your HI, but its concentration should be 57% pure. Now it will be negative, positive, negative and positive. Here will formation of Ri iodoalkane and plus H2O. This was regarding to just iodoalkane. If we want to get indirectly, then we can use for this this reaction may, this is the reaction reaction may carried out by using 95% H3PO4 phosphoric acid का भी यूज कर सकते हैं 95%. How? This is the just your Ki This is the Ki you can use over here. ROH. This is the Ki. This is the S3PO4. This is the S3PO4. Here is the removal of Hi and reacts with the ROS to give iodoalkane. This is the Ri. Rest, it will removal of KH2. This is the KH2PO4, potassium for hydrophosphate, and plus it will be removal of remaining is your one of the H, one of the OH and one of the H from here, that will be your H2O. So here is the formation of iodoalkane. Iodoalkane. So this was about the preparation of haloalkane by using halogen acid. Now I would like to go with the second part from the highlights of regarding to alcohol. This is the B part and it's a very important reaction. This is the very important reaction and that is your B part by halides of phosphorus. Halides of phosphorus. If I'll go with the halides of phosphorus, then it's a very important reaction. Mainly, basically stable halides of the phosphorus are just your PCl3, phosphorus trichloride, and PCl5. We can take over here. PCl3 is a just sp3 hybridized molecule with the pyramidal shape. Pyramidal shape. This is very important topic. Pyramidal shape. This exists, PCl5 exists in two states. One of the is your vapor or you can say liquid state, while its another state is your solid. If we'll go with the just vapor phase, then it exists in sp3 hybridization, sp3d hybridization. This is the PCl5, Cl and Cl with the sp3d hybridization. And you have discussed in 11th standard, there are two types of the bonding in PCl5. These are known as axial bonding and these are known as equatorial bonding. And axial bonding is too larger than the equatorial because of Cl के along upward direction में another Cl नहीं तो repulsion कम होगा, जबकि इसके along ये रहा Cl, इसके along ये रहा, इसके along ये रहा, तो repulsion में ज़्यादा होगा, bond length छोटी होगी, बट इसकी bond length larger होगी और bond length larger होगी तो no doubt सबसे पहले इन्हीं bonds का dissociation होगा. That's why जब भी PCl5 dissociate होगा तो ये given as just PCl3 and Cl2. This is the most important thing you have to know. And shape is your trigonal bipyramidal. Trigonal bipyramidal. This is the geometry. If we go with the solid state, then in solid form it exists in the form of dimer, and dimer is ionic, while this is the covalent. This is the ionic form. This is the covalent form. Covalent form. If we go with the ionic form, then it exists in the form of PCl4 minus and PCl. This is the 6 plus. If we go with the PCl4 minus, then it exists in tetrahedral form like this PCl. You can write it as follows. This is the PCl4 minus like this, and this is the plus PCl6 octahedral form like this. 4 Cl will be in a plane and 2 of the Cl above the plane and below the plane. With the charge, here will be your plus and here is the minus. So this was about the just PCl5. Now the time to this just discussion with the reaction. If we'll go with the alcohol, and PCl3. Then valency of phosphorus is 3. So here we'll use of 3 molecule and cleavage of OH bond like this. So here will formation of 3 molecule of RCl, chloroalkane. Chloroalkane will form and S3PO3. From the halides of the phosphorus, one thing is also important. Yield will be maximum, means yield will be around yield will be around just 80% or plus 80%, means more. That's why these processes are used to form just chloralkane. Another is this is the ROH alcohol and this is the PCl5 in the form of just axial and equatorial bond. So here will formation of RCl chloroalkane. This is the POCl3 and this is the HCl. This is the chloroalkane. This was regarding to just your halides of phosphorus. So read the matter properly. Here will formation of just chloroalkane from the both trichloride and pentachloride as a phosphorus pentachloride. This is the phosphorus trichloride and this is the phosphorus pentachloride. It exists in two forms. Now the time to discuss about the same reaction. What is that? If we want to get just bromide and iodide by this method, as a you can say, we can use PBr3 and PI3 because of both are unstable, so we can't use them directly. Here will use of indirect method. What is that? For the formation of this is the for the formation of bromide and iodide of alkyl iodide, they will use of just PBr3 and PI3 phosphorus triiodide, but both are unstable and due to instability I will not use them directly, will use indirectly. Here will use of phosphorus, this is the red phosphorus, you can say, this is the bromine Br2. On reaction with here will formation of PBr3. On balancing it will be 4, this is the 4 3 12, so it will be 6 2 12. If we want to get iodide, then we can use P4 plus I2 with the same ratio 6I2. So here will formation of PI3 as a 4. So by using these two we can get the bromide and iodide. This is the alcohol, this is the PBr3, this is the 3 molecule. So here will removal of phosphorus acid or orthophosphorus acid. 3 molecule of RBr bromoalkane plus you can say S3PO3. If you will go with this reaction, then this is the alcohol, this is the PI3, 3 molecule same. Here will formation of just 3 of RI iodoalkane and S3PO3 orthophosphorus acid, or just we can say phosphorus acid. This is the bromoalkane. So this was about the just formation of just use of halides of phosphorus. Now I would like to go with the just third method. that is the C method, by using thionyl chloride. What is that? It's very important. So this is the C reaction by thionyl chloride. It's a very important technique for the formation of chlorides. Here we'll use of alcohol because we are taking from the alcohol, plus here we'll use of SOCl2, like this you can say, and here we'll use of pyridine. If you want to go with the just formula of pyridine, then this is the C5H5N. It's an heterocyclic compound. You can write the structure as follows. This is the N, and we have discussed in the just coordination chemistry. It acts as a neutral monodentate ligand also. So this pyridine is used to absorb the HCl because it's a Lewis base. So first of all, it will formation of HCl. HCl will form in gaseous state. HCl will form in gaseous state. So we can remove it easily. And here will formation of RCl. Rest. Here will formation of SO2, sulfur dioxide gas. It is also gas. And this is the chloroalkane. This is the chloroalkane. We can say it's a best method. It's a best method to prepare pure chloroalkane. Pure chloroalkane. Why? Because adduct forms in gaseous form, they can remove easily. Because adduct forms in gaseous state, which can remove easily. That's why it's a best method for the formation of chloroalkane. But one thing also, this is also called as, this is the naming reaction. Second naming reaction we have discussed, first is as a Groves process. Now this is the second reaction, that is called as Darjan's process. This is the second naming reaction as a Darjan's process. So this was about the just formation of haloalkane from the alcohol. So we will meet in the next video. Till then, thank you, धन्यवाद, शुक्रिया. इन वीडियोस को यूं ही शेयर करते रहें, सब्सक्राइब करते रहें, आगे से आगे स्टूडेंट्स को फॉरवर्ड करते रहें ताकि उनको अधिक से अधिक हेल्प मिल सके. धन्यवाद, शुक्रिया.